All right, good morning, everybody. So today we're going to look at some properties of logarithms. This is still what I'm calling L.3. It's just continued on notes here. And we recently talked about what a logarithm is and how much basically just rewriting an exponential in a different format. So today we're going to look at some properties that occur because of that. And we're going to talk in particular practicing how do you expand logarithmic expressions and how do you condense them, and we'll use a few other items here. So some basic properties that we have. Okay. The log base b of b. What is the log base b of b? Well, if you recall how we were working on this and evaluating these, okay, rewrite them as an exponential. How would I do that? Here I would ask myself, b to the what power equals b? And the answer to that is b to the first equals b. So b, the log base b of b is 1. Okay. Second property. Okay. Again, these are basic properties. What is the log base b of 1? Well, again, if I ask myself, b to the what power equals 1. Now, if you recall, if I raise anything to the 0 power, it is always equal to 1. So the log base b of 1 equals 0. It doesn't matter what the base is. If you're taking the log of 1, it's going to equal 0. Basic property number 3, the log base b of b to the x. Same idea. Evaluate. B to the what equals b to the x. B to the what equals b to the x. Should be pretty clear that this has to be an x. The log base b of b to the x equals x. And this is a big thing that we're going to talk about with logarithms and exponentials. If you take the log with the same base of an exponential, the log base b, an exponential base b, the log base b is going to cancel out the base of the exponent, leaving us with x. And it works similarly with an exponential. B to the log base b of x. I'm taking an exponential base b to a power with a log base b. Those cancel out, leaving us with x. So these are some basic properties that we're going to be using. All right, how about some more properties here that have a little bit more to them? Okay, 3 of them that we'll be using quite a bit. First one is the product property. If I'm taking the log base b of m times n, that's a product. Now remember that logarithms are just exponentials written differently. And remind yourself, if we multiply, what do we do with exponents? If I take 2 to the third, that's a terrible 2. If I take 2 to the third times 2 to the fourth, we get 2 to the seventh. We add, don't we? If I'm taking the log of a product, I can add the logs of the individual pieces of that product. The log base b of m times n equals the log base b of m plus the log base b of n. I can split it into 2 logs as a sum. Quotient property. Well, what do we do with exponents when we divide? We subtract. The log base b of m over n, I can split it into 2 logarithms. This is the log base b of m minus the log base b of n. One logarithm becomes 2. Power property. The log base b of m to the p. Okay. We are taking an exponent to another exponent. We are taking a power to a power. What do we do when we take a power to a power? We multiply them. Okay, I'm going to rewrite this as this is p times the log base b of m. I'm multiplying this exponent by that exponent. Power to a power, you multiply. Now the way that we usually refer to this, and students like to think about it, is we can take the exponent inside a logarithm and bring it out front. The log base b of m to the p is equal to p times the log base b of m. These are our three properties that we can use to either expand or condense a logarithmic expression, and they all come from properties of exponents. We can prove all of these. I'm not interested in doing that right now. We will do that at another time to show exactly why they work. So let's get to expanding. Expanding means I'm taking a single logarithm, and what I want to do here is I want to write it as the sum of as many logarithms as I can. I want to take something that is very short and condensed and expand it out into something longer. And I'm going to be using our properties of logarithms to do this. Now, I'm going to follow my order of operations here, but kind of backwards. And I'm going to look at what's the main thing that we have to do and then work down from there. So when I look at this logarithm, by the way, it's the log of 100 over xy cubed. What's the base of this logarithm? Right, it's 10, isn't it? And we talked about that. It's called the common log. If the base isn't written, it's base 10. But we don't need that fact right now. Just wanted to refresh you. We will need that in a minute. The big thing I see in this logarithm is division. I have 100 over xy cubed. So I think, what does my property tell me about division? If I have a quotient, if I have division inside a logarithm, I can split it into the difference of the numerators, the log of the numerator and the log of the denominator. Okay. So I'm going to split this to be the log of 100 minus the log of xy cubed. Does that make sense? Okay. It should, based on the property that we know. Now I'm going to remind myself that this is 10. This is the log base 10 of 100. What is the log base 10 of 100? 100 to the what power? Excuse me. 10 to the what power is 100? That would be 2. Minus. Now we're not done, because I can look back here, and what do I notice? I notice that I have a product, that this is x times y cubed. If I have a product inside a logarithm, I can split it to the sum of logarithms. This is the log of x plus the log of y cubed. I split that product into the sum of the separate logarithms. Now, I do have a mistake right now. The way I wrote this is incorrect. Okay, take a second to see if you can figure out why. All right, now that I've paused by taking a drink of water, okay, what's incorrect with this is I'm subtracting all of this, which means I need parentheses around that. I am subtracting this logarithm, which means I'm subtracting all of that. Okay, I need to distribute that minus. All right, am I done? Or is there something else I can do with this? Okay, there is one more step that I can do. I have an exponent inside a logarithm. What do I recall about that? I can take that exponent and move it to the front of the logarithm. This is 2 minus the log of x minus, bring that 3 down in front, 3 times the log of y. I have taken a single logarithm and expanded it into the sum of several logarithms. Let's try another one. All right. Again, I see a quotient. That's the first thing I'm going to do. This is the log of z squared times the square root of x minus the log of 10. Next big thing I see, working backwards here, breaking it down, I see a product. I can split that into the sum. This is the log of z squared plus the log of the square root of x minus. All right, the log of 10. Remember that this is the log base 10 of 10. What is the log base 10 of 10? That's 1. 10 to the first is 10. That's one of our basic properties we talked about right here, number 1. All right, let's keep going. I see an exponent inside a logarithm. I can bring that exponent down in front. And it looks like that. Now, am I done? Am I finished? Okay, well, if we remember something about the square root, okay, we realize that we are not done. The square root of x, what's that the same as? Remember that the square root of x is the same as x to the 1/2 power. Okay, the second root is the same as a 1/2 exponent. So if I take a second and rewrite this as x to the 1/2, I realize that I have another exponent to bring down. This is 2 times the log of z plus 1/2 times the log of x minus 1. All right, should we keep going? Okay, flipping it around, doing the opposite, trying to condense. Okay, taking several logarithms, the sum of several logarithms, and breaking it down, kind of condensing it into a single logarithm. So if I take a look at this, I have 2 times the log of x minus, and then this is in brackets here, the log of y plus 3 log of z minus 1. Okay, basically, we want to follow the reverse order of the things that we were doing here. Okay, so here we split up a quotient into a difference. Okay, then we split up a product into a sum, and then we brought the exponents down. We'll work backwards. Bring the exponents up would be the first thing that we would want to do. I see a 2 in front of this log. I see a 3 in front of that log. Those can be written inside the logarithms as exponents. This is the log of x squared. All right, the rules work both ways. Okay, we've got equal signs in these properties, which means they can go both directions. Okay, that's what we just did here. We just went from this way back to that way. Minus, in brackets, the log of y, plus, bring that 3 up, the log of z minus 1 cubed. All right, what do we want to do next? Well, I see a minus out here, but I've got brackets around that, so I might want to take a look at what I have in brackets. I have a sum of 2 logarithms with the same base. The sum of 2 logarithms with the same base is the log of their product. This is the log of y, z minus 1 cubed. And from there, I have a difference. This is the log of subtracting between logarithms with the same base is the same as dividing within. This is x squared over y times z minus 1 cubed. Excellent. Okay, let's do one more condensing here. Notice, what logarithm do I have? I have the natural log. Now, what's the base of the natural log again? Okay, good, it's e. Right, but it doesn't make any difference. The properties of logarithms are still going to apply. So where do I want to go here? Do I have any exponents I can bring up? Yes, I do. I can bring up that 2. This is the natural log of xz minus the natural log of x square root of y plus, bring that exponent up. Now, how do I have to write this? I have to square everything inside that logarithm, which means that's the same as the natural log of y squared over z squared. Good. Now from here, I have a subtraction, I have an addition. I might as well work left to right. Subtraction. Subtracting between logarithms is the same as dividing within. This is the natural log of xz over x square root of y. Oops, that's a plus. Right. Now I have addition between logarithms. That's the same as multiplying. This is xz over x square root of y times y squared over z squared. And all of this is inside the logarithm. Now, take a look at that. You should recognize that we can do some simplifying here. I've got an x and an x that cancel out. This z is going to reduce that z squared down to a z. I have y squared over the square root of y. Now remember, the square root of y is the same as y to the 1/2. Now remember here that we need to cancel out here. I have two y's up there, I have half a y down there. And remember that this is really the same as 4 over 4, which, why would I do 4 over 4? 4 over 2. So if I take 1/2 out of that, I have the natural log of y to the 3/2. Boom. Got it. Condense that big long thing down into one simple logarithm. Last thing I want to show you is something really helpful for some logarithms that can be difficult to evaluate, the change of base formula. Let's say I asked you to evaluate this logarithm. I said, what's the log base 2 of 8? Well, you guys would say, well, 2 to the 3rd equals 8, so this is 3. That's easy to evaluate. But what if I asked you, what's the log base 2 of 10? You would say 2 to the what power is 10? Well, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. It's not a nice number, is it? It's not an integer. Would still be nice to evaluate that, and this is what the change of base formula is going to allow us to do. We can take a logarithm and change the base of the logarithm by doing the following. I can take the log base c of x over the log base c of b. Notice what I did here. I took the log of x over the log of the base. What did I change the base of the logarithms to? C. You can make c whatever you want, whatever is convenient. Now, what would make sense for us? Okay. What would be the easiest basis to change to? Well, if you look at your calculator, and I'm going to grab my calculator out right now. Okay. On the left side of my TI-84, I see a log button, L-O-G. Notice it doesn't have a base by it. That's base 10. My calculator has a button for evaluating the log base 10. So I might want to make my c equal to 10, because then I can use my calculator. Or, what other button do I have on my calculator? Well, right below the log button, I see ln, the natural log. So I might want to change the base to be e so I can use the natural log on my calculator. I'll show you how easy this is. This is the log base 8 of 75. 8 to the what power is 75? Well, 8 squared is 64. 8 cubed is 512, so it's somewhere between 2 and 3, probably closer to 2. But what if we want a better approximation than just saying, oh, it's between 2 and 3 and closer to 2? Use the change of base formula. This is the log of 75 over the log of 8. Now, what base did I change that to? I changed it to base 10, so I can type it in my calculator. I'm going to do that right now. The log of 75 divided by the log of 8. Hopefully I get a number slightly bigger than 2. It's about 2.08. There we go. Now, what if I would have changed it to something else? What if I would have changed it to the natural log of 75 over the natural log of 8? Type that in your calculator. Natural log of 75 divided by the natural log of 8. I get about 2.08. Wow! Isn't that cool? I think that's really cool that you can switch that base to be anything you want and you will always get that same approximation. Okay, how about the log base 3 of 7/8? Change the base for simplicity's sake. I'm just going to do the common log, log base 10. All right, what am I taking the log of? The log of 7/8 over the log of 3. I can type it in my calculator just like that. Or if I want, I can realize I have a difference, or excuse me, a quotient, which I can switch to a difference. You can type that in your calculator. Here's what I'm going to type in. The log of 7 minus the log of 8 over the log of 3. Any way that you do this so that you can type it in your calculator would be good. I'm doing this one. I'm making sure that I put parentheses around my numerator. Parenthesis, the log of 7 minus the log of 8. Close that parenthesis, divide it by the log of 3. I get about negative 1.2. Can that be right? Yes, it can. 3 to the what power is 7/8. That number got smaller. And we know if we're going to take something to an exponent to make it smaller, that exponent has to be negative. Last one, the log base 4 of the square root of 7. Now, you know what? Before I do that change of base formula, I'm going to change that square root of 7 to the 7 to the 1/2, which is the same as 1/2 times the log base 4 of 7. Why not? I can do that. Now I use my change of base formula. This is 1/2 times, I'm going to take the log of 7 over the log of 4. Did I have to do that? No. Am I showing off? Maybe. I'm going to type this in my calculator as the log of 7 divided by 2 times the log of 4. Log 7 divided by, I'm going to make sure I put parentheses around the bottom here, 2 log of 4. I get about 0.70. There we go. Properties of logarithms, condensing, expanding, change of base. Should be good to go. Thanks for listening.